Hi everyone, today we are going to study a very important protocol called as the Address Resolution Protocol. It is also known as ARP. Now most of the computer systems use logical addresses which are also known as IP addresses to send and receive data or messages. However, the actual communication that happens over the physical address. That means the actual communication does not use the logical IP addresses, rather it uses the physical addresses which are also known as the MAC addresses. That is from which layer? From the layer 2, which is also known as the data link layer of the OSI reference model. Now the aim here is to get the destination MAC address, right? We have the logical address, that which we call the physical address, and our aim is to get the MAC address from that logical IP address, which will help in communicating with other devices, because it is with the help of this MAC address that two devices can communicate with each other. And this is where the ARP comes into picture, because ARP is used for mapping the IP addresses to the MAC addresses. Now, the functionality of the ARP is that it helps in translating or mapping the IP address, that is the logical address, into the physical address, that is the MAC address. ARP is the most important protocol of the data link layer in the OSI reference model. It is responsible to find the hardware address, that is the physical address, which we also know as the MAC address, of a host from a known IP address. That is, if we know the IP or logical address of a host, with the help of ARP, we can find the physical or MAC address of that host. Now, how does the ARP work? Basically, when a device wants to communicate, with other device over the internet, obviously we need an internet connection for two devices to communicate. And when we have an internet connection, it's quite obvious the reason is for two or more devices to communicate with each other. So when a device wants to communicate with the other device over the internet, ARP will broadcast a packet to all the devices of the source network. That means there is one source device which wants to communicate with another destination device. So in that case, ARP from this source device will broadcast the packet to all devices on the same network. Now, the devices of the network, all the devices which after the broadcast receive the message or the data, will peel the header of the data link layer from the protocol data unit called frame. That is, in simple language, all these devices from the frame that they receive, they will peel off the header from that frame, and after peeling off the header from that frame, will transfer that packet to the network layer, which is above the data link layer. And in the network layer, the network ID of the packet which is received from the data link layer is validated with the destination IP's network ID, that is the destination IP of the device. Destination IP is the IP of that device to which you want to transmit the data. So it is then validated with the destination IP's network ID of the packet, and if it is same or if it is equal, then it responds to the source. That means then the source is provided with the MAC address of the destination to which it wants to transmit the data. Otherwise, the packet reaches the gateway of the network, and you know gateway is an interface between two different networks. So otherwise, the packet reaches the gateway of the network, and then the packet is broadcasted to the devices it is connected with, right? And then they validate their network ID. So the above process continues until the second last network device in the path reaches the destination where it gets validated, and the address resolution protocol or the ARP in turn responds with the destination MAC address. That is, it returns the destination's MAC address. Now there are some terms related to ARP which are very important for us to know. The first one is your ARP cache. Now, after resolving the MAC address, that means after finding out the MAC address from the logical address, what happens is that the ARP sends it to the source where it is stored, because it is the source which is interested in sending a packet to a destination device. And in order to transfer the packet to the destination device, the source must know the destination device's MAC address, now which it has got from the ARP. So it will save that physical address or MAC address which it received from the ARP in its table for future references, because in future also it will have to transmit some messages to the same destination. So it will store it in the table for future reference, because it would be quite impractical for the ARP to map the same logical address into MAC address again and again. So once it is done, it is stored in the table for the future references. So the subsequent communications for the same data transfer that would happen can use the MAC address from the table. Second is your ARP cache timeout. What is ARP cache timeout? That is the timeout period for the ARP cache, because you know that the MAC address is stored in the ARP cache for future communications, but that would be for a limited time period, because we know the cache size is limited and there would be many such destination addresses which would be required to be stored in the source's ARP cache. So it is not possible to accommodate all the MAC addresses. So there'll have to be a specific time slot which for which a particular MAC address can reside in the ARP's cache, and after that it will leave that space and some other new MAC address will be stored in the ARP cache. So basically ARP cache timeout indicates the time for which the MAC address in the ARP cache can reside, and after which a new MAC address would reside in the ARP cache. Okay, third is your ARP request. Basically, this is the broadcasting of a packet over the network to do what? To validate whether we came across the destination MAC address or not. So you broadcast a packet over the network. When an ARP request is sent, what do? You broadcast a packet over the network to validate whether we have come across the destination MAC address or not. Then is your ARP response and reply. So this ARP response and reply is the MAC address that the source receives from the destination, which aids in further communication of the data. So basically when the source has to send data to the destination, it must know the destination's MAC address. So ARP response reply is what? It is basically the MAC address that the source or the sender has received from the destination or the intended recipient, which will help in further communication of the data. Now there are 4 cases in this. The first case is wherein the sender is a host and wants to send a packet to another host on the same network. There is a sender, obviously, which is a host. There is a receiver, obviously, which is also a host. And then they are both on the same network. So the sender wants to send data to the host on the same network. In this case, it will use the ARP to find another host's physical address. So the sender will use ARP to find the receiver's MAC or physical address so that it can start sending the messages or the data to the destination or the intended recipient. Then there is case 2 where the sender is a host and wants to send a packet to another host on another network. Now here also obviously sender is also a host and receiver is also a host. And they want to transmit packet to host on not the same network but another network. So the sender looks at its routing table. The sender will check its routing table, and from its routing table it will find the IP address of the next router through which it can transmit the data to the destination. Then there is case 3. In case 3, sender is a router. Now please pay attention. Here the sender is not a host, it is a router. That means it received the data from an incoming line and now it is supposed to forward the data to an appropriate outgoing line, right? So the sender is a router. It received a datagram which was destined for a host on another network and not on the same network. So the router checks its routing table. Router will have its own routing table. It will check its routing table. It will find the IP address of the next router through which it can transmit the datagram so that it can reach the intended recipient. So for that, it will use ARP to find the next router's physical address, right? First of all, it will find out the IP address of the next router, and then with the help of ARP, it will map that IP address to the next router's physical address. Then is your case 4. The sender is the router here also. It has received a datagram which was received through an incoming line, and now it is supposed to again transmit that datagram through an appropriate outgoing line so that it can reach the intended recipient. So the datagram is destined for a host in the same network here. Now unlike in case 3 where the datagram was intended or destined for a host on another network, here in case 4 the datagram is destined for a host on the same network. So what it will do, it will use ARP to find the host's physical address.